want to talk about how you can implement animations in your apps. So this is something pretty cool. So announcements, we have extended the due date for the mid-semester project or the class planner project. So it's now due in 2 weeks. Okay. So it'll be due Monday 27th before class time. And this is because next Friday we won't have discussion because we have cow hacks. Um, and so next Monday we're originally thinking of like giving guys a week off. Like we won't have lecture, but we're gonna make that day a check off day for the mid semester project. Okay. So you guys have like 2 more weeks to do the projects. Yes.
No class next week.
No, there will be class next week. Um,
When
I'm sorry.
when class stuff like when we have the two class that just like broke up. No.
Um, we still have content still, so we will
So
be.
like you need any classes or not?
No, no.
So we keep every classes present.
Yes. So, but on this Monday, there won't be a lecture, but it's check off. Okay. Yeah. Um, so we're gonna still have class next week, next Monday. There will not be discussion next Friday. But on this Monday, we will have check off instead of lecture. Does that make sense? Okay, cool. Um, so yeah, class will come check off. No discussion next Friday. And it's a great time right now to start thinking about your final group teammates. Just to remind you guys that we have a final project and you'll be working in maximum groups of four. You can go solo if you want, and you will be creating a app from scratch. So you guys will be thinking of an idea, and you guys in your groups will be coding your app. And then on I forgot to announce it, but uh on the Wednesday of RRR week, I think, um, we will have a presentation day. So we're going to be in the WAS and you'll be presenting your group project to everyone. And it's a great way to kind of see what you guys have done and learn throughout the whole of the semester. So it's a really cool day. We're gonna have food and prizes and things like that. Um, but just want to take a moment to ask do you guys have any questions or concerns so far about the decal? How's it going? Is it is the workload okay? Is it too stressful? Are the content coming together? Anything at the moment? Or has it just been great? Or is it Dylan and I were really great teachers and like or like what's any questions so far or concerns? All right, cool. So here's the agenda for today. We're gonna first by talking about how does an update happen in terms of like animations. And then we're gonna talk about two types of animations that you could use. One is called explicit and the other is called implicit. We're gonna talk about different styles of animations, and that kind of goes in with the timing curves. And then we're gonna talk about this view modifier called match geometry effect, and which it allows us to kind of correlate and pair two different views, and we're able to kind of animate like basically sync them up together, which is pretty cool. All right, so let's talk about the anatomy of an update. So here we have some code, and it's basically an image of a tortoise, right? And we have it set to some size, 100 points, and it has a new view modifier we haven't seen before called scale effect. And scale effect is exactly what it sounds like. You're able to specify a number, and that's basically how much you want to scale it by. So one would be identity, there would be no scaling. Two would be 100% scaling, and so forth. And then we have this new view modifier called on tap gesture, which is basically a gesture that gets triggered when you tap on it. Um, and here we have this at state variable, right, which is simply a Boolean. And when we tap on this tortoise, what will happen? Well, it will change the value or toggle the value from false to true, true to false. And so if toggled is true, we're going to scale it up by 2. And if it's not, we're going to show the original size. So yeah, this is what it looks like. So here's the tortoise. Now, if I tap on the tortoise, you can see it immediately goes to 2. And if I tap it back, it goes back to 1, right? Back to the identity, right? So this is what it looks like, right? Um, Now this is not really animation, because an animation really is it's basically you're modifying the like I guess the you could think of animation as modifying the values from 1 to 2 or describing the behavior of how the numbers go from 1 to 2, right? So if I click on it and I want to expand it to 2, how should the numbers go from 1 to 2? Should it be like, it should be instant, or should it be like a, 1.01, 1.02, and then slowly ramp up to 2, right? So that is what we call a timing curve. So as time progresses, what is the progression of the numbers or interpolation from 1 to 2, right? But this one we have no interpolation of values, it's just 1 and then 2 exactly, right? So here we can take a look at basically the view modifiers that we have on the tortoise, right? Now, how this works is that here on the x-axis is time, and the y-axis is basically view modifiers. And I've organized it so that the first one is the most bottom applied view modifier, and then the image is on the bottom, right? So it's like in reverse order from what you see in the code. So right now we have the state we get toggled as false. And so how SwiftUI kind of manages these or view updates is via something called a transaction. So a transaction is simply it will it takes in the modified state. So at this point, let's say I clicked on it. So toggled is true now. So SwiftUI creates a new transaction. And what it does is that it goes down through each view modifier in reverse order. So it's going to go first to its on tap gesture. And it says, does on tap gesture, right? Does on tap gesture have dependency on toggled? Not really. So it moves on to the next one. Does scale effect have a dependency on toggled? And if you remember in the code, our scale effect value is derived from toggled, right? If toggled is true, scale effect should be 2. If it's false, it should be 1. So there is a dependency. So what happens is now scale effect now becomes 2 now. And then the transaction goes down. Well, does the font depend on the toggled state? It does not. So it stays the same. And it goes down to image. It does not. So then it ends. So at this point, we have updated the scale effect to be 2 now. And then the transaction closes and the review is re-rendered. Okay. Um, and so now toggle is true, and then it does the same thing, right? If you tap on it, now it's false. Okay. So it goes to kind of bottom up from the code. So it goes from the most recently applied view modifier, which is on tap gesture, and it goes up, 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 all the way up to kind of the root view. Any questions there? Okay. So, okay, so that's your code. Um, Now our difference here is that we added this with animation closure. So within our tap gesture, we have this with animation closure. And then we inside that closure, we have our state change, right? So we toggle the toggled state within this with animation. Now look at this. So now on the video, you could see now when I tap on it, it's not an instant like scaling, right? There is some kind of interpolation between the values of 1 and 2. So it's like it ramps up and then it goes, it's like it has some kind of like a spring effect, right? So this is the default animation that SwiftUI applies to this. So it applies some default behavior on how it's interpolating from 1 to 2, if that makes sense. Okay. So now it has this kind of more natural, more kind of less jagged or rigid kind of animation. And so most often or not, all you need to do is just put with animation in your code and everything would kind of work together, right? So It's just that simple to kind of apply a really simple animation into your views. So again, how it does is that, with animation, this creates a transaction. Um, so yeah, so in addition, it also has this kind of animation to be true kind of property within it. And if it says animate is true, then, we go down, right? And yeah, it just modifies the things that have dependency with to toggled. And it goes down, and it goes down. So I believe this should be true as well. But yeah, anyways, it's the same kind of logic. It goes down and then sees if it has any dependencies and then just updates it. So yeah. And so again, when the transaction ends, so the transaction basically gets created when, when there's like, for example, here with animation, right? And it applies down, oh, sorry, it basically goes bottom up and then see if there's any dependencies to this toggled state. And if there is, we basically update the new value. And in this case, with this with animation, we have this timing curve. So it basically interpolates the values from 1 and 2 according to this kind of like curve, this default curve that it applies. So again, as time goes from here to here, these are the values that it it basically, it goes slowly, so like zero, like 1, and 1.01, 1.02, 1.5, and it slowly ramps off and tapers off. Mm, Sort of looks like a sinusoidal curve, for those in math, I guess. Or like a sigmoid function, kind of. Yeah, so the big idea is animations are a function of state, right? Basically, animations are tied to state. So if the state changes, you're able to kind of see what the new value is and how we can change the values from the original value to the new value, right? And um, yeah, so transactions are created and get passed down the view hierarchy when a state changes occurs, and any, I guess, view modifiers that depend on that state gets updated, and for the next refresh cycle, it will re-update the view according to, and if it has, for example, like with animation, it will have a timing curve and interpolate the values between the original value and the new value. And Swift UI knows how to update and animate views using information from transactions. So again, that's a quick look of how a view updates in terms of animations. So now let's take a look at two different types of animations. So let's talk about explicit. So explicit is basically using with animation closure. So this code that we've seen before, that's an explicit animation because here we're explicitly saying, hey, when this, I guess, when with animation is being called, right? We basically animate the state being changed here, right? So here in this case, now we have this new view modifier called offset, and that allows us to basically specify the offset from the original position. So in this case, we're saying if toggle is true, we want to offset this by 100 points to the right. And if it's false, we offset it 100 points to the left. So now when we do this, you can see that it will kind of, go to the right and go to the left like that. Okay. So, and with the animation puts context in transactions, which tells SwiftUI to animate changes to state. So it applies timing curves to those view modifiers or that depend on some state, right? And yeah, and they're basically created at the hierarchy, and it's basically passed to all views. And so it's very easy to animate views affected by state change, but we cannot pick and choose which views we want to animate explicitly, because it automatically applies it to the whole view hierarchy. And we don't have really fine-grained controls of exactly what state we want to modify. For example, let's say you have like two states now, and you want to have like, two different behavior of how it kind of animates throughout the view hierarchy. Um, and that might cause unwanted animations. So that kind of brings us to implicit animations. Here we here we're back at the original code, um, right, with just the instant scaling and descaling. So now with this implicit, so with to create an implicit animation, use this animation view modifier that takes in a timing curve, and it will basically act upon. So if this value is changed, it will apply this timing, it will apply this animation, and will propagate it upwards. So you could rewrite the same thing that we have done with the explicit animation to an implicit animation. So, and again, it has the exact same kind of behavior. And we're going to see an example of like why sometimes you want this rather than explicit animations. So it does the exact same thing. It creates a new transaction at um, yeah. So at this point on tap gesture, we don't so it doesn't have it animate to be true because at this point there is no animation. There's nothing that says we want animation, right? So at this point, animation is like basically false. So now when we go down to animation, we can see that now we specify, hey, we want an animation for the rest of these guys. So now animation is now true, right? Animate is true. And then we go down. So now scale effect, since toggled is a dependency, right? We will apply a timing curve to interpolate the values from 1 and 2. So now scale effect will become 2. And then with a timing curve, and then we go down, font does not have dependency, and image does not have dependency. So then next, when we re-render the view, this timing curve gets applied to this scale effect. Okay. So we're able to kind of fine-grain control where we want the animation to start. Right. Because with this on tap gesture, when we had the with animation explicitly, we weren't able to specify where in the view hierarchy we want to start the animation. Right. It just started right here, right? But with animation, I could put it here, I could put it here, right? I could explicitly specify or where I want the animation to start to propagate. So here we're gonna build on top. So now we have this new view modifier called rotation effect, and that basically takes in some angle. And so if it's true, I want to rotate it 360 degrees. Else, I want to revert it back to its original kind of rotation state. So again, here's our animation view modifier. So let's take a look at what this looks like. So if I yeah, so as you can see, it applies the scale effect and also applies the rotation effect as well. So it scales up as it's rotating at the same time. And in this case, we could still achieve the same effect using with animation because, again, the rotation effect and scale effect, like we don't need to have, they both happen at the same time. So if we rewrite this using it with animation, it would still propagate the same way. Um, can anyone tell me how to rewrite this using it with animation? What would need to be changed? So right now, this is an implicit animation with a animation view modifier. How do I convert it to an explicit animation? What closure? So a with explicit animation needs a with animation closure, right? So where do I put this with animation? So there's two things need to be modified here. Does anyone know? Yes. Very good. And we put the toggle within this with animation closure. And what else do we need to change? What what do we do with this line?
Just get it.
Get rid of it, exactly. That's it. So to convert this to explicit animation, we use with animation within this on tab gesture, put toggle within this with animation closure, and delete this animation view modifier. Okay. So, all right, let's get a bit more kind of complicated. So here we have this rotation effect still. Here we have the scale effect. Here we have this implicit animation view modifier here. Here we add this new animation view modifier here as well. So there's two animation view modifiers, one being applied before the scale effect, and one being applied before the rotation effect. And here you could see for this one, right, the timing curve is this something called an interpolating spring, and we're able to specify the stiffness and damping of the spring. So in this animation view modifier, we basically asked SwiftUI to give us a default kind of timing curve. But where in this one, we're able to specify a spring effect. So like you could simulate a spring in real life, a spring has natural properties of stiffness and kind of damping properties. So damping is like, you know, after it overshoots, how much it should kind of come back together, right? And that is also we will apply this view, we will apply this animation on the changes to toggled, like we have here. So this is something we cannot do using explicit animations, right? Because we can't specify where we want animations to occur within the view hierarchy, at exact locations. Um, so yeah, those are the two things we want to keep in mind. So let's kind of take a look at how this kind of works. So here in this bottom, the first animation, right, with this default animation, that animation gets applied to the scale effect, right? So when we're creating these transactions, right, it starts at here. There's no animation needed, right? So it goes to here. Okay, we create a animation now. So we want animations as we propagate up, and we want that animation to have a default timing curve, right? And if there's any view modifiers that depend on toggled, we want to apply that timing curve to those view modifiers, like for example, like scale effect. So it's going to go up to here. We're going to animate this toggled for the scale effect from 1 to 2 using this default timing curve. And then when it goes to here, we see that we have a new animation with a different type of timing curve. And when this happens, we will take on this interpolating spring as the timing curve now, and then that gets applied to the rotation effect and everything else. Okay, so this default animation gets only applied to the scale effect, and then we go to here, we have this new animation with this new kind of timing curve, and that gets applied elsewhere. So again, with this implicit animation, you're able to specify exactly in the view hierarchy what animation type should be applied to what view modifiers. So let's take a look at the the resulting behavior. So now, do you see that? So the scaling effect is the same, right? It has that kind of like same kind of timing curve, but the rotation effect now has that kind of springiness and damping effect, right? So this is pretty cool. So for different view modifiers, right, you want to have specific behavior in terms of its animation. So with implicit animations, you're able to exactly control what animation gets applied to what. Um, does this make sense? Right? Okay, cool. And there's a bunch of other like timing curves as well that you could look in the documentation for. So we can't achieve the same effect using with animation with one state variable, right? We only have toggled here, right? And so with I guess this with animation, right? Since we only have one state variable, that gets applied, same thing all the way up here. But we're not able to specify, different animation styles. So in order to make this happen with an explicit animation, we should have two state variables, one for this one and one for this one, if that makes sense. Now with animation closure, it actually has like arguments here. So you also can specify the kind of timing curve in the argument of with animation. So yeah, that's kind of one of the differences. Any questions here? Okay, cool. So the animation view modifier, it takes in some timing curve or animation type, and it basically takes in another value. So when this value changes, it will apply this animation on that, or basically it will apply that, yeah, apply the animation on that value. Um, and so, yeah, it will monitor the value argument. And so if it changes, it will apply that animation to that, I guess, context, that value. And yeah, you're able to apply different animation styles in a single view using one, I guess, like value. So you could scale linearly and rotate as a spring, excuse me, as a spring. It allows fine-tune control over what views should be animated, and how to animate them, right? What timing curve we should use for those views. Okay, so that's explicit and implicit animations. Now let's talk about animation styles. So here we can see the kind of the function declaration of with animation. So don't worry about all of these like keywords or not. All you need to know is that it takes in some animation, right? And if you omit it, so just with animation and then the curly brackets, it will use the default animation by default, right? Else you could specify, with animation, parentheses, dot, interpolating string, blah, 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 blah. And then you put your whatever code you want to execute in the body. Okay. And then here in the implicit animation, again, it takes in some animation and it takes some value. And so whenever that value changes, it will apply that animation on that value. Okay, cool. So, right. So there's different types of animation curves. So another one is something called ease out. So it sort of looks like, it basically ramps up in the beginning and then it kind of slowly tapers off. So it looks like something like this. I don't know if it's like really apparent, but like it sort of eases off in the end a little bit. Um, so it sort of looks like this. So it ramps up in the beginning and then it kind of tapers off as time goes, progresses, right? Uh, let's take a look at another one, I think. Uh, wait, sorry. I think. Okay, there's ease in. So in this one's kind of reverse. So now we just kind of ramp up slowly and then we kind of exit out fast. There's like bouncy, so it basically overshoots in the beginning and then it kind of interpolates back and forth a little bit. And there's much more. So there's some more basic animation styles. One is linear, so it's a straight line. There's some easing functions, ease in, ease out. There is ease in and out, which is again like the one that sort of like, kind of eases in and then it kind of eases out. Sort of like again like a sigmoid function. There's springs, so there's like a default spring behavior, bouncy, there's smooth, there's a snappy spring behavior, and there's customizable springs, like the interpolating spring type that we have seen earlier. And so there's a lot more animation stuff for you to use. So you can take a look at the documentation there. But yeah, and so that's basically animations. Again, animations are tied to states. You basically can either use a with animation or implicit one, and basically SwiftUI will kind of update your views and interpolate those values to create those kind of animations that you want. So there's a view modifier called matched geometry effect, and that allows us to synchronize basically two different views that you want to correlate together and kind of animate them as the same thing. So for example, here we have Oski, this image, right? And you can see now we animate from this image to this one right here. But this one right here, this view, and this view are two different views, right? One is like in the main view and one's like a detail view. So match geometry effect allows us to specify or link up two kind of like objects or views and animate them as the same thing. So here we have a at state variable called showing full photo, and we have this something called a namespace, and it's just simply like a variable. Don't worry about this what namespace is. It's kind of like a uh yeah, don't worry about what it means. It's just like kind of like a it's kind of like a space where you could have like have a set of things in it, but like again, don't worry about what it means. Just you'll see how it's being used. So here we have this kind of if statement showing full photo, and if we are showing this full photo, we have this kind of V stack, right? This is like our detail view. We have the image, blah, 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 and then our like title caption. And then here you can see we have this matched geometry effect. It takes in an ID, and this is usually like a string. And then this specifies in what namespace that this is associated to. Again, don't worry about what this namespace is, but it's just like it's just required. And then here we have this frame for this image, and then we tap it. We have this explicit animation that toggles if it's showing true or false. And so let's say you want to have, for example, another view with also OSCI, right? So to differentiate between this OSCI and that other OSCI, you could specify different namespace so that they're like separate. So that's what the namespace is. But in practice, it doesn't really matter. Um, that scenario is like pretty like rare. So you just kind of have like one namespace and then just put it in, and then you use that same namespace in the other corresponding view. So um, and you should put your frame and other positional modifiers after the match geometry effect. So if you're modifying offset, if you're modifying position, that should be after the match geometry effect. So in this else clause, we have the same image, but now with a different frame, and we use the same ID and same transform. Sorry, namespace here. Okay, so okay. So this is what it looks like. Again, this is not the best code because a lot of this code could be refactored, right, and be contained in its own view. But just for demonstration purposes, I'm just listing the whole thing here. So yeah, so if we're showing the full photo, we show this view, and else we're showing just a simple image, right? And so when showing full photo changes from false to true, we animate between these two views. I remember that this right here um is a separate view from this view, right? Um and so when is showing full photo is true, right? This view gets kind of deleted, and then we create this view from scratch, right? And so again, these two different views, and we're able to kind of correlate this image to this image to be the same thing using this match geometry effect. Um, and so it's able to kind of know, SwiftUI is able to know how to animate the frame from 150 width and height to 300 width and height, and according, and where it should kind of be placed with the spacer as well. Okay. So so the match geometry effect matches geometry of the two images, thus allowing a smooth transition when one view gets created and one gets basically destroyed. So this is what it looks like again. So This right here is the one down here, right? And we're animating it to 300 width and height above here. Okay. Again, two different views. Uh, as we've seen in prior lecture, we talked about kind of like the structural view hierarchy, right? Of how do we differentiate views? Because since we have this if-else branch, right? These are two separate views when it comes to, identity, right? So, but with this match geometry effect, since we're able to have the same, you basically specify the same string ID in the same transform, I'm sorry, same namespace, you're able to kind of correlate these two different views together to be the same thing. And SwitchUI is able to, again, know how to animate these two different views together. Uh, cool. And you've seen this kind of effect, like for example, in the App Store. Um, Let me see if I could have an example, like of what this looks like. Um, for example, if we go to the App Store, I don't. So some like okay, no, this does not look like that. Uh, Hopefully you know what I mean. But like, if you on your iPhone, you go to your App Store, when you click on those cards, it kind of like full screen effect, right? A little bit. Um, for example, if I go to this App Store right here, right? If I click on like this card, right? Do you see how it kind of like jumps into the full screen view? Again, these are two separate views, right? Like this is like a full screen cover view modifier, I believe, right? But this right here, this image right here, right? Again, using match geometry effect, you're able to kind of correlate this view right here and correlate to this view right here in the separate view. That makes sense. And SwitchUI is able to animate between or animate that image to this, is able to animate this image, whatever this view right here, to this view as the same thing. So that is one kind of a real world example of a match geometry effect, right? So you're able to really do some really nice kind of transitions from view to another view. Okay. So to quick summarize what we learned today, again, animations in SwiftUI are functions, they're tied to state. So when something changes, right, animations get applied to your views from bottom to up. How are they being created, right? Applied? They're applied via transactions. So transactions carry information about the state, basically the values, right? And also if there is an animation or not. If there is an animation, right, we will apply timing curves to those values, to those changed of state, right? If there is no animation, we don't apply any timing curve, right? So it'd just be like, for example, a tortoise, it would just be instantly go from 1 to 2, 100% to 200%, basically. To create these transactions with animations, we can create either explicit or implicit animations. So implicit animations, we create them using the with animation closure, and that will animate all views affected by the state changed from the declaration of the with animation, right? So we create the with animation on the on tap gesture. It will apply that to all of the views of view modifiers above. Implicit animations give you more control because you're able to specify where that animation should start. And you're able to specify not only where they should start, but also the exact kind of timing curve for that. And within the kind of view hierarchy. And you're able to, have a single variable or a single state, and you're able to have multiple different animations within your view hierarchy. Match geometry effect allows you to smoothly transition the size, location of a view of two different views in two different yeah, I guess two different views, and you can correlate them together. So most often you use them to transition between identical elements, between like conditional views, like an if else, or maybe you have a view in like your list on your like home view, and you want to kind of animate that to some detail view, like a full screen cover or like a uh, or something like that. Yeah. So again, this is just scratching the surface. There are other animations tools that SwiftUI gives you. For example, there is one called a keyframe animator that was introduced in iOS 17. And what this keyframe animator does is that, like for example, in like I don't know if you guys worked with like some I don't know like some like Final Cut Pro or Adobe Premiere. There's keyframes. Like it specify at this point in time, this is what the state is. At this time, you're able to specify what different properties, right? Position and things like that. So here you're able to specify I guess like different tracks of different properties, right? So here at this track, you have this like scale. This is regarding the scale of this property, of this banner view. And at I guess at different points in time, you're able to specify different kind of behaviors to that scaling. And here is one for rotation. Um, so yeah, it's like kind of like gotta think of it as like a video editor, right? There's different tracks of different kind of properties, and you're able to kind of modify that in specific points in time. There's another one called a phase animation animator, and that allows you to create different animations, more complex animations with regarding to phases. So usually you will use this with like an enum. So maybe you want to have an animation that has like a starting, middle, and end phase. And you're able to specify exactly like what at each phase, what the behavior should be. Um, so for example, here we have like three different phases: fading in, middle, zooming out. And then here we're basically giving it all of the different cases. And then basically for each phase, right, you might have a associated like value to each phase, and you're able to kind of use that for each phase and modify your view according and applying like whatever view modifiers you want on that view. And it will basically kind of like a loop through your phases and apply those phases to your view. Uh, Yeah, so you're able to really do some more complex animations with these if you want to have more finer grain control of behavior. Yeah, cool. So yeah, that is basically it for today. Let's jump to our Kahoot.